All right, so I've got this guy set up in 2 vices again with a stop on the end because we're gonna have to flip this around 180 to do this side. We're gonna put the 30-degree bevel on it, and then we're gonna come back. I don't know if I do it. Yeah, I think we're gonna do a 30-degree bevel both sides, then come back and drill it after. It's gonna be quite a challenge. So what we're gonna do is I've set this up so the cutter is almost touching the surface here. And then I'm just gonna walk in the Y-axis until the cutter ends up removing this material here. So, because when this is correct at 30 degrees, it should just meet down here at this corner. You can see each successive pass, this ridge gets smaller and smaller. Eventually that cutter will be right at that edge and it'll be flush with this surface here, which is what I'm looking for. I'm doing a Y move in this direction, 150 thousandths each pass. All right, so I came across some weirdness, which is at this point when I reach the bottom, why do I still have this much left? Well, there's multiple reasons. One, I had designed this originally for a gravity conveyor from McMaster Carr, but they didn't have the holes in the right place. So I was trying to design for production, and so there were some other ones that were cheaper, made in America, that had the holes in the right place. So that would save a bunch of steps. So I decided to switch to those. And when I changed over, I missed something. I changed the other parts, but I didn't change these correctly. On top of that, I let the width of this just stay a little bit wide. So there's some extra material to come off there. Then I should have come back and redone this angle. Also, my angle's a little off, so there's a bunch of things like that. I checked with a 30-degree angle block, and it's like a degree or two off. All of that adds up. Fortunately, none of this is precision. This is all a prototype and rough. So I think we're gonna be okay. So I'm just gonna keep going this way. I'm gonna keep going this way until we've got the material off that I need. When I'm finished with this side, I'm just gonna flip the part around like that and do the same thing. Then we're gonna drill holes. Trying to find the center of this side here. I scribed a line using a caliper just off of the ledge I created by cutting, but I don't know how flat that ledge is because those inserts don't have square edges, so it may not be very accurate. It doesn't look like it's particularly accurate, although it's not supposed to be centered here. It's supposed to be centered on the hole, which is biased to the very edge of the conveyor. So I've got a tooling ball in here, a 1/2-inch tooling ball. That's why I drilled that small hole initially. I'm gonna have to go back and drill a 3/8 hole after. And the beauty of the tooling ball is the center of the sphere is equidistant from all points on the sphere. So left, right, I found dead center. And then I brought my electronic indicator up to just touch the tangent line and then compensate for its diameter of 0.2. And I know based on the CAD drawing that the distance from here to where I want to drill over here is a horizontal distance from that tangent point. So let's see if that's an accurate approach. So I've got my 0. Now let's go over and see if I can find the tangent. I mean, if I can find that point. When your planes aren't set up right, I just found my first mistake. So normally this indicator, the indicator is 200 thousandths diameter. So you move over 100 thousandths, which was what I did in order to find center line. But actually you move over the distance on the 30-degree plane, which is longer. And I got to go figure out what that is, and I'll be right back because this is not lining up right, but that's why, I'm pretty sure. I was killing myself here. So I got my indicator just on the bottom of this guy, set my 0. Then I compensated for the thickness, and then I made up for it's not 100 thousandths, but when you go at an angle, it's longer. It's 115.5 thousandths at 30 degrees. And then I ended up wrong. I kept figuring out, why is it wrong? Some of you might have caught it, but there it is. I set my distance from the intersecting point between the tangent and the center line of this over to where the center line would be on the other one. So when this center line is in this location, it is tangent with this circle, which is the 1/2-inch tooling ball. and then move over 2.3832, and the center axis of this will again be on the center of my hole, which is right on the scribe line where I measured from the bottom here. And that was really a rough measurement, but it's really close because the scribe is right on there. Always check your work. Every time I don't, I get punished. However, when I didn't do is I didn't lower the table enough to fit the chuck in here, so I can actually drill the holes and tap these parts. So as a result, I've got to lower this down, and when I lower this down, all my measurements will be wrong. But at least I know the line that's scribed there is very accurate. All right, so I can't drill all the way through this, or I'll end up cutting into my parallel or my vise, because it's going to come out right through this corner here. So we've got to do blind holes, and we're going to go 675 thousandths deep. Unfortunately, my quill DRO is hard to read because it's way down. And that should be the last thing I need to do at 30 degrees. I thought I was about adding the intermediate holes that go every 3 inches. I just don't think they're necessary. There's not a ton of force on this part, so I could always update it later if needed be, but these are 3/8 inch bolts, and there's not a ton of weight here, so I think it's going to be fine. Time to retram the head, but I also have to pull the column back. I don't normally leave it this far forward. I don't know how much you'll be able to see this, but to tram in my head, I use a square gauge block as my set. It took a ton of back and forth between this orientation and this orientation in order to get this close. This way, it's within half a thou, and you can see that just leaning on the vise is enough to shift that, and that's not even that much force that I'm putting on there. So I'm going to leave that be, because just tightening the bolts throws it off that half thousandth even when I try different patterns. So I get it right on, then it's off, so I'd have to compensate off and figure out how to get there. This direction, it's within like 2/10. So I'm going to call that good, and we'll move on to the next operation, hopefully the final. All right, next up, we're just going to remove these little high spots and relieve this section. We're going to go below the base here by 25 thousandths. Second relief cut. That's it. The last part should be done. Now we just need to assemble it. Well, deburr and assemble. Here's a quick video showing one of the seam welders. This is a smaller one. The top unit is the power pack. That unit below that we just looked at is the chiller for the laser, because they all require it. There's the Weld Logic control panel with their software. There's a camera that shoots straight down the same pipe the laser is shooting down, so you can see exactly where you're shooting. There's the fingers that hold it down, and the argon sprayer essentially, and there's also argon that goes through the head of the laser to cool it and clear. Then there's some adjustments on the side of the laser to choose, because there's a galvo head on there, and it lets you do wobble. And this is underneath, and this is where the lift guard goes, although that's going to rotate about 90 degrees. As you'll see in these still shots I have after of the completed assembly. So the clamps are up top here. That's those copper fingers, and it's sort of like a finger bend, a bender. And those clamp down, and then the welder goes right down the middle. And the reason they use copper is because there's a ton of heat they got to get rid of. And also underneath, you can see a hose that feeds argon to a channel so that the back of the weld also is covered in argon. This is the state the gravity conveyors arrive in. Because there's a lot of bouncing in transportation and they have a spring-loaded pin on one side, apparently the bouncing around makes the pin retract enough that a lot of them fall out. And so I had to reseat all of them before I could use it. Here you see the two gravity conveyors mounted onto the lift table. You can't see any of the stuff I made because it's all underneath the gravity conveyors. The next shot will show it. This whole assembly is ready to slide under the 6-foot seam welder, and it will support cylinders between 6 inches and 32 inches, although they think they want an additional piece that goes across the top that you can press smaller cylinders on. By top, I mean across the top of the gravity conveyors, there'll be a plate that goes across that can push up small cylinders. In the side shot, you can see the angle plates mounted, and then that weird shaped 1-inch plate is in between the two gravity conveyors, so it's still hard to see even from this angle. I think they could really benefit from a nice coat of paint, but this is just a prototype to see if it'll work. By the way, this is a hydraulic lift table with remote control. Pretty nice. Next up, I can highlight some of my screw-ups. Here is the 3/4 inch end mill going into the material and stalling out and spinning in the holder. Remember I said I never had a problem with that? Well, as soon as I said that, I knew the machining gods would punish me, and they did. It freezes up. Not very good. And as if it wasn't enough punishment the first time, we might as well go for a second time with even smaller bite. The first time I was trying to take the whole thing. Second time, only about 0.38 inches. And there we go. Which actually has enough force that it pulls the entire head assembly of the mill out, and I have to reset up everything. Pretty awesome. And I'm really lucky it didn't damage the part worse than it did. Fortunately, that punishment did not come forth. Thanks for watching. Hope you find it useful. Hope to see you next time.